All right, time to work some examples. So in the lesson, I gave you the guideline of what to follow with sine and cosine. I also did it with tan and secant. But again, certainly those are more complicated. The sine and cosine ones are a bit more straightforward. So here, the very first one I gave you, probably the easiest one. Only one is odd. If there's only one that's odd, that is the one you split up. Now you have to split it up in a way that creates a du. That's always the goal of this, right? You're going to do a u substitution, and I'm going to do it. So you're going to split up cosine third as cosine squared times cosine 1. What you did was basically split this apart to create yourself a du. You need a u. And I told you that the u is always going to be the opposite of the one that you split apart. So that means that the u is going to be sine x. And the du, hello, it's right there. Derivative of sine is cosine. I'm going to be very careful about writing this with my x's and dx's. Now, again, I will write them on the side. I probably should have written them before, but I didn't. So these are the two main identities that you're going to use to substitute, right? You're not going to mess with sine 4. You never mess with the one that you don't split apart. You mess with the one that you split apart. So I split it apart cosine. That means that what has to happen is this has to go away. You can't have that there. I need everything else to be the same trig dude so that I could make the u substitution. I could not do that right now. So I need to use my identity where cosine squared is. I'm going to put sine squared. So you replace cosine squared with 1 minus sine squared because that's the identity. This cos x dx is still hanging out there, right? This is only going to go away when I put my du there. So that's the first step. Split apart, replace with the trig identity. Now I'm going to distribute. You need to do it. Sine to the fourth times 1 is sine to the fourth, right? Boop. And now over here. Now, this is where people screw this up. There's a minus between them. People will do these two. I see it all the time. They'll tell me that sine 4 times sine 2 is sine 8 because they'll just multiply it together. But, right, rules of exponents, you got to add the powers. I mean, obviously, a ridiculous algebraic mistake like that at this level in the course, it's just, you cannot make mistakes like that at this level, right? I mean, it's Calc 2. So this is going to give you sine 6. You add the powers together. And then I'm going to keep my parentheses. My dot should be outside that. I like to write the dot. You don't have to write the dot. Now, I have him in position, right? I split him apart. That's my du. I replaced him with sine because I need everything to be sine so I can use my u. So now I'm going to replace everything. That is u to the fourth. That is u to the sixth. And this is du. And this is what we did a million times. I know a lot of students like to get here and then they just start doing it. Add one, divide, add one, divide. They like to just skip this part. But this is an important part. I mean, you're doing a u substitution. That's the point of splitting it up. So I want to see that you did the u substitution correctly. So as I said, you add 1 to the power, divide by the new power, or flip it over, right? Add 1, it becomes 7. Flip that over, it becomes 1 over 7. Whatever you like. At this point, it doesn't matter. The whole numbers, right? And then you have your plus c, right? So that's the u substitution part. You integrated it, and now just put back the sign. This is why I know a lot of people like to skip from here to the end. I mean, you really shouldn't. If you do everything perfect, maybe I'll look the other way. It all depends. So, but that's the game, right? We had one that was odd. We split that one up. That was my du. So my u was the opposite. I used my trig identity to replace the one. Right? You need them all to be the same so that you can do the u substitution. All right, so do another one. Okay, so the second one only involves one trig dude. And I relocated my trig identities and wrote them a little neater. So you don't have a choice. You have to, if there's only one, that's the one that you have to split up. So you're going to split it up. And again, you're going to split off 1. You're going to write sine squared times sine, right? This is the reason that you do this. That's my du. So what I already said to you was the u is always the opposite of the one you put here. Now, don't switch signs. Don't put negative cosine. It doesn't work that way, right? So the u is just the other trig dude. There's only 2 trig dudes, sine or cosine. The u is either sine or it's cosine. So if you see that you pulled apart a sine, that is the du. So the u is the opposite. Now remember, the derivative of cosine is negative sine. This is where it gets a little more complicated because it doesn't quite match because of that, but I'll offset that at the end. Now, if this is going to be the du, then this needs to be the u, and it's not in the correct form. That's why I have to replace him, right? So once again, you're going to replace him with his identity, which is right there. Sine squared is equal to 1 minus cosine squared. So you're going to replace that 1 minus cosine squared. Now, I'm going to put my parentheses because I'm very careful because it's two things now times that. I mean, I got it. I'm set. Whoops. I'm anticipating my next step. So now I'm going to do all of my substitutions. Be very, very careful. This is where it's easy to screw up. That's why I'm doing this example. That stays 1. You don't make a u substitution on something that doesn't have a cosine in it. This has the cosine in it. So you get that. Now, here's where the part you got to be really careful. I want to replace this with du, except the du has a negative there. See, this is where my dot is bad. My dot looks like a minus. So you're going to put negative du in its place, right? That negative would have to go from this side to this side. So if I want to replace sine x dx, I have to put negative du in its place. Now, I don't want to deal with this minus sign. So here's where I play my little cheating game. I take my negative, I put it here, and I put it here. The negative is going to turn this into a positive, right? A minus and a minus make a plus. So that makes u squared. This is a positive 1. This negative has to hit them both. So that turns the positive 1 into a negative 1. And then it allows me to keep the du the way that I want. Now, this is the part where, tricky. This is easy to do. My u looks a little weird. Add 1, flip it over, right? You're going to make it u to the third. So you divide by 3, or you do what I say, which is flip it over and throw it in the front. Same damn thing. Now, here's where people mess up because people will put x here. Now, certainly if I gave you this, you started off with something, you took its derivative, and you got 1. That thing would have been x. No problem. But if it's not dx, if it's du, see, you're not, that's the whole purpose of doing a u substitution. You have switched the variable of integration from x to u. So when you are integrating, the integral of 1 du is u, right? The derivative of u is 1. So you put a u here. It's very easy to mess that up. That's why I'm taking the time to go over and explain it. It's not dx, so you cannot put an x there. It'll screw up, and it's going to screw up your answer. So the u was cosine. So now just put it back. So you're going to have cosine cubed of x, right? Putting back the originals, minus cosine x plus c. That's important because if you mess up, so it's easy to make a mistake like that. And listen, things happen. But you do have to pay attention when we do the more complicated one, which comes after this. The trig substitution, you really switching variables badly. I mean, you're switching to thetas. How can I like it? So, but this, it's important that you don't put x there for that. All right. So same thing. It was odd. There was only one of them. Split it apart. That's my du. My u is the opposite. I use my trig identity right there to replace the sine squared. I switched my signs because the du didn't quite match exactly. And then I integrated, and I did it very carefully. All right, so now I'm going to skip 3 because 3 is a little redundant. But I am going to jump to 4. All right, so this is 4. Like I said, 3, 3 is very similar to problem 1, so it gets redundant. At some point, they're repetitive. Now, I'm doing this one because it's more complicated. And at some point, you'll see me cheat and switch to just S and C because it's a lot of writing. So they're both odd. Right? The situation where one is odd and one is even is simple. You split up the odd one. But when they're both odd, you want to split up the one that has the smaller power, which in this case, conveniently, is cosine. That was by design. So I'm going to do the split up step a little differently. I mean, I'm going to do this first. Right? I'm going to pull apart 1. That's my du. Right? I pull off 1. So then I know that my u is going to be the opposite one, which is sine, right? So my du, the derivative of sine is cosine. There it is. Yay! But my problem is here. I don't have an identity for that. I have an identity for cosine squared and sine squared. There they are. So what you have to do is split up the cos 4 again. But you have to split it up clever. You don't make it cos 3, cos 1. You have to make it cos 2, cos 2, so you can use this. So now here's just for convenience, I have to start switching it. So I'm going to write sine 7. I'm going to take cosine 4 and split it up as cosine squared, cosine squared. And I still have my cosine dx there. Now, why did I do that? So that I can replace each of these separately, one at a time, with the identities. So for cosine squared, I'm going to put 1 minus sine squared. And then for that cosine squared, I'm going to put 1 minus sine squared. Now you might be wondering if I'd let you do that. I would absolutely let you do that because this gets to be a lot of writing. And I don't want to keep writing cosine squared, sine squared, cosine squared, cosine. It's ridiculous. It gets to be a lot. I will at some point put it back. So cos 4 had to be cos 2, cos 2. So you replace the identity twice. Now, here's where people get really messed up. My advice to you is to times these together first. Worry about this after. Just pretend it's not even there. Do this FOIL, right? First, outer, inner, last. Distribute that first. That is exactly what I'm going to do. 1 times 1, you have 1 minus sine squared. That was my first and my outer. Now my inner gives you a negative sine squared. And then the last, right? Negative and negative is positive. Sine squared and sine squared makes sine 4. And I still have my cosine dx there. So now, at some point, I'm going to run out of room here. So I'm going to combine what I can. I have 1. You have a minus sine squared and a minus sine squared. That's minus 2 sine squareds. And then plus your sine 4. And then your cosine dx. Now I'm going to distribute this one, right? Let's go green. And green doesn't work. I love it. And I stole this one from my math department, and it still doesn't write. I'll have to do red. So red, right? You're going to distribute. Now, again, be careful. Like I said in the previous example, this is where people screw up. They'll tell me 14, and then they'll tell me 28. This is ridiculous. You add these powers together. So again, I'm out of room, so I'm going to come over here. So you get sine 7. You get minus 2, add them, sine 9. And then at the end, you get plus, you're going to do sine 7, sine 4. That gives you sine 11, right? Again, we're adding the powers. And then I have my cosine dx. Now I'm going to replace everything. Make them all into u, right? This is sine, this is sine, this is sine, this is cosine dx. So you're going to have u to the 7th minus 2u9 plus u11 times du, right? That was the du. Now you just integrate it. Really simple, one at a time. You get 1/8 u8. Now be careful here. You're going to add that, right? It's going to become u10. But then you have to divide by the 10. Right? So you add 1 to the power to make 10, but then you got to divide by 10. And there's already a 2 there, so you got to reduce that. And then over there, you're going to go 1 over 12, u to 12, plus c, never forget the plus c. So remember, the u was sine. So now just put it back. The problem is over. I'm going to simplify there. This is where I stop cheating and just writing s. I'm going to write sine x. This is 1/5, because it's 2 over 10. So that's sine 10. And then 1 over 12, sine 12. It's hard not to write on a slant. I tend to start writing downward as I do these. It just barely fit there. So this, was it more complicated? A little more complicated. It's just, it gets kind of nasty. That you could see that, I mean, pretend this had been cosine 6. You would have had to do cosine 2, cosine 2, cosine 2. I mean, it gets pretty bad. This is about as bad as it would ever get. Right, so I started with the 5, I split it apart. So I have my du. That lets me do that part. Right, once that's du, I know that the u is sine. I have to split cosine 4 with 2 and 2, so I can use the identities. I did that, so now I created everything with sine. And then at this point, this is algebra, FOIL, distributing, adding the powers together, just so that I have everything else as sine. And then I can do the u substitution. Everybody's sine, so I can put u where all the signs were. All right, now I'm going to do an even one, just to show you how it's done. Okay, number 5, the 1 even. 2 even's a problem, but one you can handle. Splitting this up, right? The whole thing was if it's odd, you split them up. But if it's even, what's there to split up? You're gonna write cosine times cosine, and then what? Those identities don't have cosine in them. You're like, oh, but cosine is 1 minus sine. No, it's not. Right? That's not an identity. So splitting this up gets you nowhere. What you have to do is you have to know to replace it with the other formula, which tells you that cosine squared, I guess I'll write it here. Cosine squared is equal to 1/2 plus 1/2 cos 2x. Right? They call that the half angle because it's halves. So this is the substitution that you have to make. You're not, some people will get here and they'll put 1 minus sine squared. Where does that take you? What do you? It's the same situation. You have sine squared. You can't pull that apart. What's your du? Right? You say, okay, but the u is sine, but there's no du. I mean, you can't do a u substitution if you don't have part of the thing there, right? I mean, you need a u and a du. So you always need another trig, guys. So that's why when it's even, it's a lot more complicated because splitting it apart doesn't work. You have to just use the proper identity. Now, it's not that bad. Now, I'm going to be very careful with this. You're going to integrate 1/2, and you're going to integrate, because I don't want you to get confused, and it's easy to get confused what to do with this other 1/2. Technically, there's a dx here. I'm being bad. I got to write it. Right? You're integrating the 1/2, and you're integrating this. This is a u substitution, right? The u is 2x. So remember, though, when we were doing integration by parts, I told you it's time to start doing these in your mind a little quicker. And the trick was to take whatever's there, flip it over, and put it in the front. So first, we're going to integrate 1/2 dx. Now, notice I did not switch, right? I'm not doing a u substitution here. You can do it here, but I'm going to do it without doing it. I don't need to. I'm just pointing out to you that this is a u substitution you could do. This one is not. This is dx. So this is just 1/2 x. The derivative of 1/2 x is 1/2, right? The x would go away. Now here, remember, the derivative of cos, right, was the antiderivative. The derivative of sine of 2x would be cosine 2x times 2, right? Chain rule. Derivative of sine u is cosine u du. But I have a half there. That's a problem. Not really. I told you what to do. So I know that this answer is going to be sine 2x. I told you take this 2, flip it over, and put it in the front. But there's already a 1/2 there. Yes, there is. So you have to account for that. So you would keep the 1/2 there. You would take this 2, flip it over, put it in front. And that's going to make 1/4, right? 1/2 times 1/2 is 1/4. Now the question is, did the sign change? The derivative of sine is not negative cosine. The derivative of sine is cosine. And there's a plus there. So it stays plus. So the sign didn't change. Let me make my plus look prettier. And then my plus c. So now I can check it really easily. This derivative is cos 2x times 2. But I had a 1/4 there. And then that 2 eats that 4, and you get a half. So that works. Derivative of that is that. And it works. Because if you combine those into this is equal to that by the identity. So it's not that it's difficult. It's not. You just have to know when you see an even to make this substitution instead of one of the other two, because one of the other two don't lead you anywhere. Well, anywhere that you can do. Now I am going to reluctantly, I will start this other one. I put it there, but I'll start it. All right, so number 6. I do know why I put it there. I really shouldn't have put it there, but I did put it there. Just to introduce you to a negative. So you have sine third. Just like with the power rule, right? I mean, if I asked you to integrate 1 over x to the 4th, right? I mean, this is day one crap. You can't integrate that. You have to rewrite it this way, right? You have to write it so that you can use the reverse power rule, right? The integration rule, add 1. So you have to do the same thing here. Just because it's a trig function doesn't mean you're doing a different thing. You're going to take that and make it cos minus 4. Now, minus 4 is even. Even if it wasn't, you don't split apart the negative, you're going to do it wrong. So, yeah, the other one's odd. So this is the one you would split apart. You would have your sine squared. you'd have your cos minus 4, and then you'd pull off the sine x dx. I'm going to stop in a second, but I just want to show you the beginning of it. Once again, here, you replace it with 1 minus cosine squared. And here's where we got to be a little careful. You're still going to have sine x dx. That's going to be my du. My u has to be cosine. Right? Remember, whichever one is here, the opposite one is the u. But remember, the derivative of cosine is negative sine. So I'll end up putting a negative here. Distribute the c minus 4, right? The cos minus 4. So you get cos minus 4. This part's where you got to be careful. You have cos 2 times cos minus 4. Remember the exponent rule. Add the powers. So you're adding negative 4 and 2. So think of it this way. All right, minus 4 plus 2 is minus 2. And then you have that. And then you would do the thing at this point. You would put negative du there, right? It doesn't match. Move the negative to there. And then this would be u minus 4 minus u minus 2. Then I would switch them. I'd make this one plus. I'd make this one minus. Add 1, divide. Add 1, divide. It's not that difficult. All right, but you get negative powers in your answer. So you'd have to be careful with it. Beyond this point, no matter what I give you, they are redundant. It's always the same game. Split apart the smaller odd power. If they're both even, you're totally screwed. You have to use the more complicated formulas if they're even. If there's two evens though, you got a problem. I mean, if I gave you sine 4 cos squared, or sine squared cos squared, which I did give you a number 9, it's a lot more complicated. So the even powers are not your friend, but the odd powers are. So I worked as many as I can. Like I said, they get repetitive. It's always the same game. You're trying to pull off one of the trig guys. That's always the du. So the opposite one is always the u. And then you just carefully make your substitutions. Make sure you do the exponent parts correct. That's a mistake I see at this level. People don't do the exponents right, and it messes up the whole problem. All right, so in the next video, I will work with the tangent and the secant ones. These are a lot more complicated than these are, because those derivatives are more complicated. These derivatives are the best. Sine, cosine, negative sine. It's easy. All right, so hopefully again, it helped.